Welcome back, children. Today we have to discuss some properties of determinants. There are 6 properties of determinants. The first property is the value of the determinant remains unchanged if its rows and columns are interchanged. That means let delta is equal to determinant a1, a2, a3, b1, b2, b3 and c1, c2, c3. The property says that this value of the determinant remains unchanged if its rows and columns are interchanged. That is the transpose, like for matrix, rows and columns are interchanged, we get transpose of that matrix. So here delta is this determinant. Let delta 1 is equal to interchange rows and columns. So a1, a2, a3, b1, b2, b3, c1, c2, c3. So property says that this delta and delta 1 are equal. Let us check an example. Determinant 2 minus 3, 5 and 6, 0, 4. The next one 1, 5 minus 7. Let delta is equal to this determinant. So value of the determinant is equal to, here I expand along R1, 2 into, delete the row and column, we get 2 by 2 determinant, cross multiply, so it is minus 20. Then next element minus of minus 3, delete the row and column, so 6, 4, 1 minus 7. So cross multiply, minus 7 into 6 is minus 42, then minus 4, then plus 5 into, delete the row and column, 6, 0, 1, 5. So it is 30 minus 0, 30. Now find the value. Minus 40 plus 3 into minus 46 plus 150. So minus 40, then 46 into 3, 138 plus 150. So that's equal to minus 178 plus 150. That is minus 28. So this is the value of this determinant. Then we have to check whether value of the determinant is same if we interchange rows and columns. So delta 1 is equal to determinant 2 minus 3, 5, 6, 0, 4 and 1, 5 minus 7. So that's equal to 2 into 0 minus 20 is minus 20 and minus 6 into minus 3 into minus 7, that is 21 minus 25, then plus 1 into minus 12 minus 0. So that's equal to minus 40. Here it is minus 4. Minus 4 into minus 6 becomes 24. Then minus 12. That is minus 52 plus 24. Is it minus 28? So this delta and delta 1 are equal. So what is the first property? The value of the determinant remains unchanged if its rows and columns are interchanged. Or we can write simply like this, determinant A and determinant A transpose, both are equal. Now the next property, property number 2. The property number 2 is if we interchange any 2 rows or any 2 columns, then sign of the determinant changes. If we interchange any 2 rows or any 2 columns of a determinant, then the sign, positive becomes negative, negative becomes positive, like that. The sign of the determinant changes. So let delta is equal to this one, then delta 1. Interchange any 2 rows or any 2 columns. So here I can interchange R1 and R3. The notation for that is R1 interchange to R3. Do you remember this? The first chapter we learned R1 and R3 interchange. So So the first row becomes C1, C2, C3. The next is B1, B2, B3. And the last one is A1, A2, A3. So property says that delta 1 is negative of delta. So we can verify this taking one example. So in the last example we have the determinant delta is equal to 2 minus 3, 5, 6, 0, 4 and the third row is 1, 5, minus 7. Its value is minus 28 from the previous example. Then let delta 1. You can interchange any two rows or any two columns. Suppose let R1 and R2 interchange. So we can write 6, 0, 4 in the first row, 2 minus 3, 5, then 1, 5, minus 7. And we can find the value. Expanding along R1, 6 into bracket 21 minus 25. The next element is 0, 0 into that is equal to 0. So the next one is 4 into, delete the row and column, 10 plus 3. So that is 6 into minus 4, then plus 4 into 13, that is minus 24 plus 13 into 4 is 52, so that is 28. So look this delta 1 and delta is minus 28 but delta 1 is 28. So its sign change. So the property is when we interchange any two rows or any two columns of a determinant, then value of the sign of the determinant changes. Now the third property, property 3 is if in a determinant any two rows or two columns are identical, identical means corresponding elements are same, then value of the determinant is 0. For example, let determinant delta is equal to 3, 2, 3, 2, 2, 3, here R1 and R3 are identical, that is corresponding elements 3, 3, 2, 2, 3, 3 corresponding elements are same. And what is the value of this determinant? Expansion along R1, 3 into, delete the row and column, 2 into 3 minus 2 into 3. Then minus 2 into 2 into 3, that is 6 minus 9. Then plus 3 into 2 into 2, that is 4, 4 minus 6. So 3 into 0 minus 2 into minus 3 plus 3 into minus 2. That is 0 plus 6 minus 6, that is equal to 0. So the property is when in a determinant, if two rows or two columns are identical, then value is equal to, value of the determinant is equal to 0. Now the fourth property is if we multiply the elements of any row or column of a determinant by a constant k, then value of the determinant gets multiplied by k. Once again, if all elements of a row or a column multiply by a constant k, then value of the determinant is multiplied, that gets multiplied by that constant k. So let delta is equal to this determinant, delta 1. Let delta 1 is equal to k into a1, k into a2, k into a3, that is R1. R1 implies k R. Multiply R1 by the constant k. Then next is B1, B2, B3. Next is C1, C2, C3. So the property says this is equal to K times delta. Okay, that is K is common in the first row, we can take outside, then that into, this is actually K into A1, A2, A3, B1, B2, B3, C1, C2, C3, and this is same as delta, so K into delta. So by this property we can take out any common factor from any one row or column. We can verify this. Example, delta, as in the previous example, delta is equal to 2 minus 3, 5, 6, 0, 4, and the last is 1, 5, minus 7. Its value is minus 28. Let delta 1 is equal to we can multiply R2. R2 implies 2 times R2, that is multiply R2 by 2. So delta 1 is equal to new determinant 2 minus 3, 5, 6 into 2, 12, 0, 8, 1, 5, minus 7. Then what is the value of this? 2 into 0 minus 40, then plus 3 into 12 minus 7 minus 8, then plus 5 into 12 into 5, 60, 60 minus 0. So minus 80, then here minus 3 into minus 92, then plus 300. So what is the value of that? That is minus 80 plus 92 into 3 is 276, that is minus sign, plus 300. So that is 300 minus 276 plus 80, 356. So that's equal to minus 56. Minus 56. Is minus 56 is minus 28 into 2. Minus 28 is the value of this determinant. Then here the delta 1 means we multiply the second row by 2. So we can conclude that delta 1 is 2 times delta. We multiply the first determinant, the second row we multiply by 2. So the new determinant delta 1 is equal to that 2 into delta. So the property is, if each element of a row or a column is multiplied by k, by a constant k, then value of the determinant gets multiplied by k. And by this property we can take out any common factor from any one row or a column. This property is very, very important. Now the next property. Next property is, if sum or all elements of a row or a column is expressed as sum of 2 or more terms, then the whole determinant we can express as sum of 2 or more determinants. That means, look here, delta is equal to A1 plus lambda 1, A2 plus lambda 2, then A3 plus lambda 3. The second row B1, B2, B3, C1, C2, C3. So here the first row is, that is R1 is sum of each element, R1, each element is the sum of 2 terms, So we can express this determinant as A1. The first element we can write here A1, A2, A3, B1, B2, B3, C1, C2, C3 plus in the first row we have lambda 1. So lambda 1 you have to write here, then lambda 2, then lambda 3. Then the remaining rows same B1, B2, B3, C1, C2, C3. So we can express delta as sum of two determinants. So the property is here the first row is sum of two terms. So the whole determinant we can express as sum of two determinants. And you look here how we split. The first row is A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3. So first in the first determinant we write the first elements only A1, A2, A3. Remaining rows same. The second determinant we write the second elements lambda 1, lambda 2, lambda 3. Then remaining element same. So this way we can express. So one example. Determinant x, y, z, a, b, c, then x plus a, y plus b and z plus c. What is the value of this determinant? Without expanding, using the properties we can find the value of determinant without expanding it. So which property we apply here? This x, y, z, a, b, c, x plus a, y plus b, z plus c. Here the third column is sum of two terms. So we can express this whole determinant as sum of two determinants. Okay. So the first column is x, y, z. The second column is a, b, c. Here you have to split. So in the first determinant it is x, y, z. Then the second determinant x, y, z, a, b, c. And the last column is again a, b, c. So look children, it is not like matrix addition. In the last chapter we studied matrix addition. Matrix addition means we add two matrices. How we add the corresponding elements we add. But for determinants, if this determinant plus this determinant, we can't add x and x. Like matrix addition we can't add. The addition is only for the last column. The first column and here first column same. So that you have to write x, y, z itself. Then second and here second column same. So just we write a, b, c. But third column different, that you can add. So it is x plus a, y plus b, z plus c. This way you have to split. Now what is the value of this determinant? Here this first column and the last column same. They are identical. So by property number 3 its value is equal to 0. Now the second determinant, second column and third column same. So again its value 0. So we get 0. So value of this determinant is equal to 0. Here we apply property. This property number 5 we applied, then property number 3. So the property number 4 is if sum or all elements of a row or column is expressed as sum of two or more terms, then the whole determinant we can express as sum of two or more determinants. Then the last property, property 6. Property 6 is let delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. Let delta 1 is equal to delta 1, R1 we change as R1 plus K R3. So what is the meaning? We multiply the third row by the constant K, then that is added to this first row. This type of operation we studied in last chapter, elementary operations. There are three operations we discussed. First operation is we can interchange any two rows or any two columns. Then C also possible, column also possible. The third one, second one is like this. One column or row we can multiply the all elements of a column or a row by a constant K. Then the last property is multiply the all elements of a row or column by a constant, then add these elements to the corresponding elements of any other row or column. So we can write like this, R3 R3 plus K R2. This type of operations possible. These are known as elementary operations or elementary transformations. So same here I applied, multiply the last row by K, then that is added to first row. So the first row becomes A1 plus K into C1, A2 plus K into C2, A3 plus K into C3. Then second row B1, B2, B3. Third row C1, C2, C3. Now what is the value of this? Here the first row is all the elements of first row, sum of two terms. So we can split it into two determinants. Which are the two determinants? A1, A2, A3. B1, B2, B3, C1, C2, C3. The second determinant is KC1, KC2, KC3, then B1, B2, B3, C1, C2, C3. Now the first determinant is same as delta plus the second one, K is common in the first row, so we can take outside by the property number 4. Then we can write like this. Okay. So that's equal to delta plus K into, what is the value of this determinant? Here first row and last row, they are identical. So by property number 3, its value is equal to 0. So K into 0. So that's equal to delta. So delta 1 is equal to delta. That means if the property says like this, property number 6, that is if to each element of a row or a column, the equi-multiples of the corresponding elements of any other row or column are added, then the value of the determinant remains same. If to each elements of a row or column, here in the first row, the equi-multiples, that is this KC1, KC2, KC3 are added. So we get like this, then the value of the determinant remains same. That is the property number 6. So once again we can revise. Property 1 is the value of the determinants remains unchanged if its rows and columns are interchanged. That means determinant A and determinant A transpose both are same. The second property is if we interchange any two rows or any two columns of a determinant, then sign of the determinant changes. The third one is if any two rows or two columns are identical, the value of the determinant is 0. Then fourth one is if each element of a row or a column multiplied by a constant K, then value of the determinant gets multiplied by K. By using that property, we can take out any common factor from any one row or a column. Then property number 5 is each element of a row, if some or all elements of a row or a column expressed as sum of 2 or more terms, then the whole determinant we can express as sum of 2 or more determinants. And the last property is if to each element of a row or column the equi-multiples of any other row or column are added, then value of the determinant remains same. I hope all of you understood this session.